Hello everyone, this is ES81A1 and I am here to present some solutions for selected problems of the book Advanced Engineering Mathematics by Ray Wiley 5th edition. This is Roland Abao and let's begin. Our first problem is we need to solve d squared times the quantity of d plus 5y is equal to x plus e to the negative 5x. This can be written, we multiply this equation and we have here d cubed y plus 5d squared y is equal to x plus e to the negative 5x. This could be written as y triple prime plus 5y double prime is equal to x plus e to the negative 5x. To solve this, we need to find the yc, and we have its characteristic equation m cubed plus 5m squared is equal to 0 for the homogeneous part. We factor out m squared, and we have here m squared times the quantity of m plus 5 is equal to 0. Finding for the roots, we have m squared or m is equal to 0, which is repeated twice, and m is equal to negative 5. So finally, we now have our yc, which is equal to c sub 1 plus c sub 2 x plus c sub 3 times e to the negative 5x. The next step is finding yp using undetermined coefficients method. We have here a guess on yp because g of x is equal to x plus e to the negative 5x. So we now have this unknowns ax plus b, which is multiplied to x squared because we have already a constant times x in our yc, and this part we have x times the constant c times e to the negative 5x. Now, getting the first derivative, we have yp prime is equal to 3ax squared plus 2bx minus 5x c e to the negative 5x plus e plus c e to the negative 5x. For its second derivative, y double prime p is equal to 6ax plus 2b minus 10c times e to the negative 5x plus 25c e to the negative 5x. For its third derivative, we have yp triple prime is equal to 6a plus 75c times e to the negative 5x minus 125x c times e to the negative 5x. Now we have y triple prime p or yp triple prime, which is from the original equation, plus 5yp double prime is equal to x plus e to the negative 5x. Now substituting for this value from here, we have 6a plus 75c e to the negative 5x minus 125x c times e to the negative 5x plus 5 times the quantity of y double prime p, which is 6ax plus 2b minus 10c e to the negative 5x plus 25c e to the negative 5x, which is equal to x plus e to the negative 5x. Now simplifying this line of the equation, we get 6a plus 30ax plus 10b plus 25c e to the negative 5x is equal to x plus e to the negative 5x. Now we can see from here 25c, it is multiplied to e to the negative 5x, just like here. So we got here 25c is equal to 1. So computing for c, we now have c is equal to 1 over 25. For a, we have here, it is with x, and we have here x which has a coefficient of 1. So we have 30a is equal to 1. Finding for a, we have a is equal to 1 over 30. Now for the remaining constant 6a and 10b, we have here 6a plus 10b is equal to 0. We now substitute a to this equation, and that's why we have b is equal to negative 1 over 50. We now get our yp solution, which is equal to 1 over 30x cubed minus 1 over 50x squared plus 1 over 25e to the negative 5x. Now for its general solution, we have y is equal to yc plus yp, which is equal to c sub 1 plus c sub 2 x plus c sub 3 times e to the negative 5x plus this yp, which is equal to 1 over 30x cubed minus 1 over 50x squared plus 1 over 25e to the negative 5x. So we now have our final answer. For our next problem, it is taken on from page 107, number 51. It has the instruction, construct a linear combination of functions suitable for finding a particular integral of the given differential equation. We have here d squared plus 4 cubed times the quantity of d plus 1y is equal to 10 e to the x plus 3x squared times sine 2x. It can be written in this form. So we now have y prime plus y times the quantity of y double prime plus 4y cubed is equal to 10 times e to the x plus 3x squared sine 2x. For finding yc, we have our characteristic equation, which is this: m plus 1 times m squared plus 4 cubed is equal to 0. So this is a homogeneous equation. We now have the roots. One of the root is m is equal to negative 1, and the other 6 roots, because this is a 7th order differential equation, we have positive, negative 2i, which is repeated 3 times, so that constitute the 7 roots. Now we have this yc from these roots. Yc is equal to c sub 1 times e to the x, to the negative x I mean, plus the quantity of c sub 2 plus x times c sub 3 plus x squared times c sub 4, that is multiplied by cosine of 2x plus the quantity of c5 plus x times c6 plus x squared c7 quantity multiplied by sine 2x. Now have this yc. Now finding for yp, because g of x is equal to 10 times e to the x plus 3 times x squared sine 2x, we have here a table. The form of g of x is just like this number 11. So we can guess that its form of yp is equal to ax squared plus bx plus c cosine 4x plus x squared plus fx plus g sine of 4x. So from this reference, we can now get our yp, which is equal to 8c sub 8 e to the x, which is from here. And for this part, for 3x squared sine 2x, we have the form of yp to be like this. C sub 9 plus x c sub 10 plus x squared c sub 11 times cosine 2x. If you can see, it was multiplied by x cubed because this part of the solution has been already taken in yc. So it is multiplied by x cubed so that it can have a unique solution. It is furthermore added to x cubed, the same with this one. It was multiplied x cubed times the quantity of c sub 12 plus x c sub 13 plus x cubed c sub 14 quantity times times sine 2x. Simplifying it, we have here yp is equal to c sub 8 times e to the x plus the quantity of x cubed c sub 9 plus x to the 4th c sub 10 plus x to the 5th c sub 11 quantity times cosine 2x plus the quantity of x cubed c sub 12 plus x 4th c sub 13 plus x to the 5th c sub 14 quantity multiplied to sine of 2x. Now we have here our final answer. We have y is equal to yc plus yp, which is equal to c sub 1 times e to the negative x plus the quantity of c sub 2 plus x times c sub 3 plus x squared c sub 4 quantity times cosine of 2x plus c sub 5 plus x times c sub 6 plus x squared times c sub 7 quantity multiplied to sine of 2x plus c sub 8 times e to the x plus the quantity of x to the 4th c sub 10 plus x to the 5th c sub 11 quantity times cosine of 2x plus x cubed c sub 12 plus x to the 4th c sub 13 plus x to the 5th c sub 14 quantity multiplied to sine of 2x. So the instruction says that specific values of the coefficients need not to be found. So this is now our final answer. Thank you for listening. See you again. Bye-bye.